first I wanted to show you some diagrams, which unfortunately you cannot see tables. That you have to see the network neutrality debate in the context of how broadband really works in the United States. So the United States, unfortunately, has low broadband penetration on fixed lines and low broadband speeds on fixed lines and relatively high pricing. And the slide I was going to show you shows that the United States is number 15 in the penetration of rate of broadband fixed lines, and it's 2 positions below Greece. While Greece, as you know, has had 8 years of crisis, so and much lower income per capita than the United States. So that's not a good position to be in. And it's also lagging in speed. You can see speeds of other countries like Switzerland, Denmark, Netherlands, France, Norway, much faster than what we get on the average here.
Has this changed? Has the United States used to be faster, didn't it? Has it sort of fallen behind, or has it always been sort of a?
I think one of the issues was that the Federal Communications Commission defined broadband as something pretty slow. So the companies thought, well, we can be called broadband even though we are relatively slow. But it doesn't have, the United States doesn't have so much fiber deployed. So that's what puts it on the slow side. And also a lot of the coaxial and stuff like that, they are not really reaching the over 30 megabits per second range. And so
is there less investment in the United States?
Yes. That's what I was going to say, that was the next diagram. Wow. Now you start seeing. I'm not. Can I use that?
Yes, just want to test it.
I don't think it moved. I'm clicking. Oh yeah, I can do that.
Or just click it with the cursor now so you can.
Okay, you're good. Oh, that's okay.
Use the fingers.
Use the fingers.
If it's like the most sensitive.
You were talking about America's technology.
I'll go back. So anyway, so I was going to tell you that the investment in infrastructure is smaller. Oh, great. We go to the. I was going to say that the investment in infrastructure is relatively low and fees are high. So one of the reasons why we have low penetration is because the average price for a broadband connection is about $39 per month. That's high. I mean, if you go to a place like France, which has higher speed than the United States, that connection is 20 euros. Well, 20 euros, it's approximately $26, $27 per month. That's a big difference between 27 and 39. So you have relatively poor households unable to connect, and that's what we have.
So where's the money go?
Profits of the telecom companies and cable companies, they're doing well. And as an aside, and if we're fixing the picture here, you can see that one of the biggest telecom companies in the United States, the AT&T, decided to stop investing in telecommunications and invest in content. I mean, so right now, the only big real telecom company is Verizon. I mean, the other ones bailed out. And given how much money they spend on buying Time Warner, they don't have money really for networking investments. So it's interesting. I mean, I think it's kind of on the side because everybody focused on the antitrust issue of that case. But it's interesting that, you know, one of the biggest telecom companies in the United States decided to forget about telecommunications. So don't worry about it. Okay, so fees are high, investment is low. So now I don't really need the picture. because I wanted to show you the picture of the internet without drawing it from scratch. What's your expectation?
I should come up. I'm just reading. I just
Well, while that's coming up, in other countries,
Yeah.
the like in France,
Yeah.
the money is not going to the profits. Is that a different market structure? Is that regulation?
It's a kind of a success of the regulatory structure they have in Europe and a failure of the regulatory structure we have here. Because the technology is the same, right? There's no big difference between the networks that they have in France versus the network that we have here. But what France did was starting from a more monopolized environment than us, because they had France Telecom full monopoly to start with. They imposed a requirement for wholesale pricing. So they imposed a requirement that every one of these telecom companies, especially France Telecom, would be required to sell any service at a wholesale price to anybody else. So these intermediaries that arose, buying at wholesale and selling retail, managed to suppress the prices. And I think to some extent was also the government pressure. I think things work differently in Europe than the United States. In Europe, the government pressure works. You know, the government tells people, do this, they do it. Here, it doesn't matter. They bring the lawyers. They say, we're not going to do it unless the Supreme Court says it's okay. Well,
on the other hand, you know, the United States has some very successful tech companies in other, like Apple making iPhones or Google providing services, Amazon. Is that unrelated, or do you think that there may be winners in some categories and not others?
I think it's a different period for the telecom companies than what Google's period today. The high-tech period of AT&T was in the end of the 19th century. That's when they created the big network. That's what they were high-tech and so on. Right now, they're considered a utility company. That is, if they make money, they have to redistribute to the shareholders.
That's what I was thinking. Is maybe are the incentives aligned so that there's more incentive for creation? You know, I don't know whether you call that downstream or whatever say Apple making handset or designing the handsets.
Well, you know, Apple designed things on its own, the way they wanted them, without any restrictions, and that was fine for them. Google, to a large extent, benefited from the fact that the telecom companies and the cable companies weren't interfering with what they were doing is sending stuff through. And therefore, Google can say, well, we're going to do anything we want. I mean, AT&T and Verizon and the cable guys at some point in time could have been competitors of Google, but they didn't try.
Right.
They never tried. So we have a pretty old-fashioned companies as our telecom companies. And the cable guys also were very low-tech for a very long time. All they were doing is just rebroadcasting some images, and now they're not, but they're still taking a very passive role. Okay, so in the corner you have internet service providers. Okay. And in particular, these are crucial because these are the ones of households. So somebody like AT&T would be here, and it's the one that provides services to households. On the other side, you have ISPs of Google or a different ISP for. This was showing the 15th position of the United States in penetration. This was showing higher speeds in other countries compared to the United States. This was showing high revenues for the telecom companies, but low infrastructure investment. Okay, let's go to this because this is crucial. So you have the backbone up here, which is long distance internet services. Then you have local ISPs and ISPs on the other side of Netflix and Google and so on. And these arrows show the money flow. So what do I mean by that? Each one of these people pays their ISP, and the ISP pays the backbone according to the amount of traffic, according to the amount of traffic transported. And this has been there since the beginning of the commercialization of the internet, let's say 91, 92. Okay, so this is already there. But what happened in 2005 is that AT&T said, well, we don't make enough money from our residential business here, from our subscribers, so we want to start charging directly companies on the other side of the internet, such as Netflix and Google. This wasn't an issue of these companies not paying to start with, not paying the backbone, because the way the backbone is set up, both sides pay the backbone, okay? But it was an issue for AT&T to exercise its market power. AT&T has market power over residential customers because there are not that many competitors there.
So when they were paying for the internet backbone, they weren't paying AT&T, they were paying...
Well, no, the internet backbone, the biggest network, the biggest backbone network is AT&T.
Okay, but you're saying that part wasn't what they were asking to be paid for?
No, they were saying, here we are, a local ISP, yeah. We have market power over these guys. Unfortunately, we cannot charge them more, so we want to charge them maybe even a bit less and collect a lot of money from this side. And the interesting thing is that they weren't trying to collect from other ISPs like these guys, but they were trying to collect directly from the companies. And they would say anybody who has content. The proposal of AT&T was actually as follows. Everybody who has content is going to be offered a contract that gives them a choice of prioritization. This prioritization costs some money, and if you buy it, we'll make sure your information packets are prioritized, they arrive first. If you don't buy it, we cannot guarantee that. Your information packets might be slow. And the idea is that this is going to be offered to everyone who has content, all the way from Netflix with huge amount of content, then to Google, then to MIT, to NYU, and so on. Yes?
What do you define as the internet backbone? Is it, you're defining as like commercial internet services?
Correct.
Or is it, okay, so
it's commercial, but think of it as long distance, because the typical contract that an ISP has with some backbone company is delivery of the whole internet to us with a certain bandwidth. This is the traditional contract called transit. Did I answer your question?
I'm just wondering what would be ISP providing commercial internet service at the same ones that was providing residential service, with the exception of like very localized.
Could be. Could be, yeah. But the fact is that it's a different type of service. See, here we're talking about long distance fiber optic service throughout the United States. We have excess capacity. We have only a few contact points in every city. So the competition is very intense here. So AT&T and Verizon, even though they have big portions of the internet backbone, they cannot really make much money from this. Okay, so on the other hand, here, as a residential customer, in a residential network, thank you. Yeah, as a residential network, they can make money because there are not so many competitors. Typically, you have two competitors, one a telephone company and one a cable company. Okay, so keep this in mind because this is going to be our basic understanding. So essentially, since its commercialization, the internet has been a decentralized network with minimal intervention. Typically, the ISPs do not prioritize packets, and definitely there is no paid prioritization. So if we go to the previous slide, these S's of whatever fees AT&T wanted to collect are all zero, and they're up to now they're still all zero. So this world was called network neutrality. It's just a name coined up. I mean, It's just a fancy name. Okay. So then the problem arose in 2005 when the then CEO of AT&T was asked in an interview with Businessweek, how do we deal with this so-called internet upstarts at the time? And he said, look, I mean, it doesn't matter because we own the pipes. And that was quickly after the Southwestern Bell had bought AT&T and changed its name to AT&T. And Southwestern Bell, so AT&T had those pipes, the backbone, and everything else on the internet. Says we're not going to let them use them for free. The internet can't be free because we have made investments and we need to recover our investments. That's essentially what he's saying. It cannot be free. But if you read this carefully, it's based on the idea that it's presently free and we cannot continue to be free. And that's why we need to start doing paid prioritization. And in fact, it's wrong because the basic service that ISPs buy on the internet, and they buy from the backbone, is called transit, and they pay for it. So there is no free lunch. There is no, especially a CEO of a telecom company must know that this is not, the internet is set up from 92, doesn't allow anybody not to pay. Okay, everybody pays. And MIT would pay its ISP, the ISP would pay the backbone. It will not be, there is nobody else there who will not pay. And in fact, as I was telling you a minute ago, the internet backbone gets paid twice when the transmission happens because they're paid from the originator and from the terminator side. Okay, so what's the idea of a violation of a network neutrality? The ISP creates, let's say, 2 lanes, and the proposal of AT&T was for N lanes, but let's say 2 lanes. And if a company such as Google, Microsoft, Netflix, and so on pays the residential ISP, its transmission is delivered first. If that creates an artificial quality difference between the searches, okay? And it's artificial because it's not natural. It's not necessarily there because of congestion or other reasons. It's there because AT&T set it up, okay? And given that quality difference, search companies would be willing to pay to be in the fast lane. I think if this actually gets implemented, I find it very natural that all the search companies are going to say, okay, we're very upset that we're paying, but we're paying. Yeah, because otherwise, the delay, even of a few seconds in the search results might give a big advantage to the rivals.
There's also some kind of content that doesn't matter delayed. Like if you're doing a video or a phone, you want to, it's very annoying if it's even just a fraction of a second delayed.
Yes.
But if it's, if you're transmitting a file, then
yes,
it doesn't matter.
That's right. That wouldn't matter. But I think that the people who were although in principle AT&T would charge money to NYU and MIT, I think it's extremely unlikely that they would do that. They would try to get money from Google for search results, not necessarily for YouTube downloads, but for search results, because the search results are very few in terms of quantity, but they're very valuable. So if you create restrictions on them, it's the easiest way to make money on that. But they would also, AT&T was also thinking of putting it on Netflix because, if there are delays, then you might be stuck in the middle of the movie that you are downloading. Okay, it creates artificial scarcity. So now,
well, I'm not sure why he's calling it artificial. I mean, there is scarcity. I mean, not everyone can go fast.
Not necessarily.
No,
actually,
who goes fast and who doesn't go fast, don't you? I mean, if everyone could go fast, isn't part of the problem that there are these. So
there is. Since this thing started, it has been 13 years, and there have been a number of regulatory proceedings in which the telecom companies every time have the opportunity to say, here is our data on scarcity. There is actual scarcity. They never did. I don't think there is scarcity.
Well, why? How come when I do video conferences and stuff, sometimes it's staggered, not close to
I don't know how much bandwidth we're trying to get at the same time, and I don't know what your where your bottleneck is. I mean, I knowing NYU, I know that many times on stuff like that, the bottleneck is within NYU and not when we go outside. So, but from the point of view of AT&T, okay, if there is scarcity, then we monetize the scarcity. That's part of it. If there isn't, we make sure we create some so that we can make money.
Right.
Okay. So, okay. Now let me talk about
so whatever level of scarcity may have been, they can make more money by creating more scarcity.
Exactly, and the incentives are a bit perverse because you would think that the incentive should be to expand bandwidth, make more investment. But if you make money from scarcity, the incentive is the opposite, not to invest and keep it scarce. Okay, let me talk about the levels of network neutrality, because this is the words are used in a loose way. So here is the strictest way. So absolute non-discrimination, no quality variation of service for money or for free. So this was the original idea, which was proposed by Tim Wu, who's a professor at Columbia Law, and he coined the word network neutrality. His idea would be, absolute non-discrimination. Now, in practice, what has happened throughout time up to now, even in the regime of network neutrality, is that some varying quality of service is offered, but there are no fees charged. And what do I mean by that? Why would a telecom company offer some difference in quality of service? For the reason that Eric just said. You send the video, they want to make sure that the video comes all at the same time. So when they sense that you're sending video, they try to give you priority. They try to make sure, let's make sure that this whole thing shows together. But they don't ask for money. So because they don't ask for money, I say this is also network neutrality. Now, number 3 is what is called tier service. So essentially, you create different lanes and you charge according to what lane you're in. Now, this is neutrality within the lane, but of course, no neutrality across lanes. So this is not really network neutrality, even though in some early the Obama administration, they were calling this, the lawyers of Obama were calling this network neutrality, but I don't think it is. Number 4 is identity-based discrimination allowed. So I have 2 companies, let's say Yahoo and Google. I know Google makes a lot of money. I know Yahoo doesn't make much money. So for the same thing, I charge more Google. Okay, so this is identity-based discrimination. Of course, 3 is not net neutrality, 4 is not net neutrality. And 5, full exclusivity. Full exclusivity would mean that I create some lane, the fast lane, and I tell companies in search, like Google and Microsoft, that only one of you 2 is going to get to be in that lane. So then I can auction this monopoly position and make as much money as possible. Okay, so this is the most extreme. So we went from 2 network neutrality setups and 3 non-network neutrality setups. Okay, so let me, I don't know if you have seen such diagrams, but these are kind of general diagrams of platforms. And on the one side, you have here consumers, and on the other side, you have content and application providers. And of course, the consumers might be paying somebody like Netflix, or might not be paying somebody like Google. They definitely pay the platform. And the issue of network neutrality is about this price, this fee that the platform may collect from Google, from the content provider. So the platform's objective is obviously profit. And in different setups, we have seen that this S might be optimally set by the platform as positive or negative. For example, on the internet that we're talking about today, or on game platforms, this S you can show is the optimal S for the platform positive. On the other hand, when we are in operating systems like Windows, you can show that the optimal S from the point of view of Microsoft is S negative, because they want more apps to be developed. So they want to subsidize apps. So this is just a general note on that this thing is not necessarily always positive, but it depends on the economics of the case. But keep in mind that what we should be really trying to maximize is not the profits of the platform, but society's objective. And society's objective here, I'll call it total surplus, or maybe some people call it welfare, but it has three parts here. Not usually it has two parts, consumer surplus and profit. But here there are two different types of profits. So there's consumer surplus, profits of ISPs, and profits of content and app providers. So if you look at the whole ecosystem, you should try to maximize the whole thing. Does this make sense? And then the question that we want to ask is, given that we're trying to maximize this, should this S be positive, 0, and so on? And remember, under net neutrality, it's 0. Okay, so I won't go into this in detail. This was an early attempt of the Federal Communications Commission to define network neutrality. So the crucial thing was this. Well, the fact that there was going to be transparency and no blocking is no big deal. Everybody agreed on. The question is whether there would be discrimination allowed. And the way the FCC wrote it as no unreasonable discrimination, which begs the question what's reasonable and what's unreasonable, which means a number of years of fights among the lawyers. So this was the early attempt. So this was a weak net neutrality proposed in 2010. But despite that, Verizon sued and succeeded. And essentially succeeded because the FCC had classified internet service under what is called Title I in the regulation as an information service. So what's an information service? I mean, to us, usually an information service means looking at the database. Now, the internet is hardly looking in a database. When we have internet transmissions, it's like communications. It's like picking up the phone in older times. So it doesn't really make sense that it was classified as under Title I. But what happened was that the DC Court of Appeals told the FCC, as long as you bring it in as under Title I, we will never approve it. So pushed that way, the FCC brought it under Title II. So Title II is a stricter way of imposing discrimination, and it's a traditional way that telephone calls from 1934 to now have been regulated. There is no way that the telephone company might charge you more for a phone call because they think you make more money, for example. Or if two investment bankers talk, AT&T cannot charge them more than if two poor people talk. Okay, so and that's because of non-discrimination. Okay, so in the end, because of that, the FCC passed new rules in February 15. They were upheld in 2016, and they were under strict discrimination under Title II. In particular, they do not allow paid prioritization, and the scope of the regulation was increased. So instead of applying just to fix, that regulation applied to fixed and wireless communications. The telecom, a lobbying group for the telecom industry sued at the Court of Appeals to stop the rules. But given that Title II allows the FCC to do practically anything, the rules were upheld. So that's what happened in 2016. But with a new administration in 2017, the FCC reversed the rules, took back the 2015-16 regulation and said the net neutrality is dead. Okay, so the companies can do any contract they want really. This has been appealed by consumer groups and technology associations, and there is no decision yet on anything like that. Additionally, Congress passed a resolution, but not the Senate, saying that since there was no change in the underlying conditions between 15 and 17, the FCC made a mistake by changing the result. So essentially, with the assumptions didn't change, the result should have been the same. So that's kind of that idea. Additionally, various states, including big states like California, have said recently that they have jurisdiction over the internet, and not the federal government, not the Federal Communications Commission. And some of them did it by executive action of the governor. Some of them did it through legislation. But I actually think that this kind of approach has practically no probability of success, because for many years, internet service is considered an interstate service, and being an interstate service, it's governed by the Federal Communications Commission. So it doesn't matter what California or Massachusetts say. I think it's unlikely that they're going to win. And I see it more as a political thing in which we say we did something rather than it's going to be effective. There is also another approach that some states have proposed. They said, look, I mean, we do state business with these companies. Like we use AT&T for our phone system in Albany, New York. Maybe what we do is tell AT&T that unless you commit to net neutrality, you don't get any contract from us. Now, whether this is legal or not, don't ask me. I don't really know. But I've seen it reported from various states, this idea there. Okay. So what would be the result of a violation of net neutrality? And by the way, despite the fact that the present regime allows for violations of net neutrality, except for a corner of the issue, which is something called zero. What's called zero? Sorry. Zero rating, right? Exactly. Except for that, and if I have time, I'll talk in the end about zero rating. But except for that, nothing really. There hasn't been other violations. But the big violation would be the lanes. And the winners of each type of service could be chosen by the residential ISPs. And an effect of that would be a reduction of innovation at the edge of the network. And besides a general reduction at the edge of the network, I'm also worried of calcification or freezing of industry structure. I mean, companies come that are new, and when they're new, they don't have much money. So think of Google before its IPO. If net neutrality was killed before then, and AT&T was collecting fees, then only Yahoo would be our search engine today. I don't think that Google would have made it because they didn't have the right amount of money. So this is kind of freezing innovation and freezing the industry structure and killing innovation. And these kind of effects are difficult to quantify, but we all think that they're very, very important for the growth of the US and world economy. There is also this issue, ISP favoring their own telecom and video services. This is something that, in principle, the FCC can deal with because they have dealt with such similar kind of things before. So I wouldn't worry about this so much. I think they have a tradition of doing it. I worry much more about the innovation issues. There is also the news diversity concerns, and there are various groups in Washington that have made special pleadings to the courts on this issue. The idea being that if some news organization pays for prioritization, the news are going to come out first. It's unlikely that that people are going to read the news of the other organizations. The ISP's defense, the first defense is that the net neutrality can never be optimal if there is protection. The second defense was that net neutrality would result in less investment in bandwidth. But I'll show you in a minute that both of them are wrong. Okay. Now, residential ISPs of market power. This is one of the papers I wrote without congestion. So essentially, this paper without congestion shows that total surplus is maximized under network neutrality. Okay? And then the ISP said, the previous thing I was telling you, that, okay, what about the congestion and what about the investment in bandwidth? And because of that, Ben Hermelin and I wrote this paper because we assume congestion, and we showed that for a wide class of utility function, net neutrality is optimal, and it could also characterize for which utility function net neutrality would not be optimal. And I'll show you. Okay. Additionally, we showed that even when network neutrality is welfare optimal, the ISP wants to create paid prioritization. And the reason for that is because the ISP has a different objective function. And the objective function of the ISP is just his own profits, while we are adding in our objective function consumer surplus and profits of the companies at the edge. Okay, what about this claim that net neutrality will reduce infrastructure investment? On that issue, the academic literature is divided, because on the one hand, lack of net neutrality should increase profits as the constraint is relaxed. On the other hand, the price discrimination scheme requires scarcity. So it gives an incentive for the company not to invest in extra bandwidth. Okay, so and different models, not only that, but different models. There are models have been written, and different models have opposite results. So ISPs may invest more or less under network neutrality, depending, first of all, on the bandwidth expansion function. What kind of technology do we have for expanding bandwidth, and the degree of appropriation by ISPs of the consumer surplus. This problem is mathematically complicated because there are too many things floating around, and you have to make some strong assumptions on who appropriates the consumer surplus and to what extent. So depending on that, you're going to get different results on that.
Can you think of this as a bit of a basic monopoly problem, that monopolists will want to restrict supply to increase profit, but if there's more competition, then that problem goes away. So the ISPs are going to have this perverse incentive to restrict bandwidth when they have monopoly power, but if there's competition, then they won't have that bad.
Eric, this is a good point. This whole analysis is under the assumption that the ISPs have monopoly power, have some market power. Because if we had, if in every part of the United States we had 4 or 5 ISPs competing, I don't think we would need any regulation. We would let them compete and things are going to work out. One of the frustrating problems in this setup is that when AT&T said, we want to kill network neutrality, all the other ISPs said the same thing. Okay, and we didn't have the possibility that, let's say, Comcast or some other ISP in competition with AT&T would say, well, we are going to stick with network neutrality no matter what AT&T does. So that would have at least created the possibility of competition on the basis of
but they have to be competition in each local market. Like,
correct.
It doesn't matter how many ISPs there are if there's only 1 or 2 in each market.
That's correct. No, I mean, when we're talking about 5 in this area, in its zip code or something like that.
Yeah, you need something like that
Yeah.
to get competition. Yeah. But I mean, it seems like this, this, as far as you can think of it exactly like a monopoly problem of monopolists restricting supply.
Correct. I mean, if these guys did not have market power, the problem could not be important, because then regulation would be kind of redundant. It will get to Trump's position. Regulation is redundant. But here, I think regulation is not redundant because this is the only way out of the mess.
Do other countries have competition? Is there anything, or is it just a cost too high to have competition?
I don't think we have many countries with more than a few ISPs, more than a couple. And in some countries, there's only one. There's only one, and then there are resellers of the wholesale service of that one. Because many countries don't have, keep in mind, many countries don't have cable. And therefore, you're relying almost 100% on
technologically, it's not possible to have multiple competing people.
It's feasible, but it's expensive.
Yeah, I mean,
Yeah, it's all cost effective. Yeah, but here there is the other issue when we talk about extra investment. What kind of technology do we have for bandwidth expansion? Because there presently in the United States, except for wireless, there is 3 fixed technologies. You know, one is coaxial cable of the telephone companies. One is cable, coaxial cable, and then I'm sorry, I meant coaxial cable. Telephone companies, I should say, copper wire cable. Then for the cable companies, coaxial, and for and fiber optic. Now, fiber optic in the United States is extremely limited, and there is a tiny bit of satellite transmission, but that's also tiny and very expensive. So,
what about, you said that's for wireless, but what about 4G, 5G? Will that solve this problem? Will it be?
Well, there is a chance, having done a lot of work on 5G, there is a chance that 5G will solve the problem. Why? Because I don't know if you know that 5Gs are waves, so-called millimeter waves of high frequency that do not go through walls. So they're considered low quality waves. At the same time, their transmission rates are extremely high. So they're 100 to 1,000 times faster in transmission rates than traditional, 3G, 4G waves that we use right now. So that gives the possibility of having a system which is kind of fixed wireless. So we put let's call it cell transmitter inside here in this room or inside this building, and once it's inside, the transmission rates for video are going to be equally good as the ones you get from fiber. So that possibility does exist, and the only people who have actually deployed any 5G is Verizon, and they have deployed it in this manner, like fixed houses with bandwidth. But the 5G is a huge amount of spectrum, which has not been allocated. In fact, Verizon has a really tiny amount, and AT&T has also a tiny amount, but these amounts are completely tiny compared to the. So there is a possibility there. Whether it's going to happen or not depends to a large extent on whether the telephone companies are going to take up on that. And as I said, I mean, here you have one of the biggest ones, AT&T, with no money. So I don't see them being able to do anything. Yes.
In most cases, these companies are using lens and all those technologies anyway. For 5G feasible or deployable at a massive scale, they still need to build out fiber, or they still need to use copper.
Correct.
They need a wired line in order to build out the wired like in order to broadcast the 5G.
Yes, but I mean, existing telephone companies, existing wireless companies have, pretty big network of fiber, so they could add it on top of it. Now, a completely new telephone company, suppose XYZ company comes in, that they would have a hard time, and that's why it's unlikely that this is going to happen. So coming back to your question, for a long time, I would say there is no future, there is no possibility in wireless. But now I think there is a possibility, but whether it happens or not, I wouldn't bet on it.
So the way it would be done would be like there'd be receivers in each person's house or apartment building.
Yes.
And then that would get the bandwidth to the building, and then after that, you could use whatever's inside the building.
That's right.
And then you could have lots of competitors delivering the bandwidth to the building, I guess, theoretically, right?
Theoretically, yes, but practically, I'm not so sure if it's going to be
fixed cost. You don't have to dig holes in the road. You just have a transmitter.
Yeah, I mean, it's hard to create the network in the roads. I mean, it's expensive.
That's the expensive part. But if you did it wirelessly, then
yes. If you did it wirelessly, yes. But then you would need to use some wireless thing that would penetrate. You might need to use 4G to get to a certain.
Well, as long as you had the antennas being compatible, part of it is have one antenna for all 5G. Then whether it's
I guess it's possible. Yeah, I can see it happening in this building or in NYU's building easily, right? We put some antennas on the top of the building, and now whether it's going to be cost effective in the suburbs, I'm not sure. I mean, it's going to be an interesting question. I've been doing this study for NSF with some people from engineering at NYU, and the engineering people assured me that the cost of deploying the network is comparable to the cost of the traditional networks.
Okay.
So it's not much cheaper, not much different, but the capacity, the speed that are achieved by this are much larger. So anyway, it's an interesting thing, but I don't know. I mean, we will know in a couple of years. This thing is, although Verizon said they're going to have appliances by Christmas, I don't believe it so much. I mean, it's going to be kind of fractured.
So we have about maybe 5
minutes. Okay, so 5 minutes. So maybe I should open it to discussion. I was going to tell you to give you an idea.
There's another question back. Slide. Go back 1 slide or 2 about.
Oops, I'm going back in the wrong. Okay, hold on. Slide or 2. This one or before that.
The one about congestion. Okay. Cannot be uploaded. There's no congestion. So if there is congestion, then sometimes network relevant. Is that kind of like the ski lift pricing that Paul Romer did, or whatever, where you have the average, the marginal are the same?
It has to do with something. Let me show you a couple of slides because and then I'll stop because we have to.
Because normally you'd think that with congestion you would want to have some way of prioritizing.
Yes, you're right, but it turns out to be something really esoteric. I'll show you in a second. Okay, so this is the model. Essentially, you have various providers provide x-axis the quantity, and we allow for the possibility of subdivision of of pipes, and we assume congestion. So there is some delay because not all the throughput can come through the pipe.
Mm-hmm.
All right. So each consumer buys a bundle of different types of content. Consumers dislike delay in general, plus they might dislike delay of particular types of content too. And we're trying to maximize total surplus, which is consumer surplus plus ISP profit plus content profits. Okay, now this I won't really discuss. This is the utility function we're using. But what I'm going to try to say is our main theorem, because this is important. We can show that given that utility function, which is very, very, very general, total surplus is maximized when content throughput is maximized. Now, this is a very important theorem because once you have done that, then everything else that you're going to do is going to be, how do we make the throughput out? So if we manage to show that welfare is proportional to throughput, then the question is how we're going to maximize it. And the reason for this is that content is kind of like income. It has the biggest positive effect when there are no restrictions. If we created restrictions from the lanes, it would be, we would create a distortion. Now, okay, so our question is, network neutrality, no prioritization is welfare superior to any division of bandwidth if no division of bandwidth leads to more content being coming.
So I'm not sure. So I'm not sure I get the answer to that, because suppose you have some very low value bandwidth.
Yeah.
People are, backing up something and they're sending lots and lots of files, and someone else is doing a critical phone call with their grandchild.
Okay.
And now they can't talk to their grandchild because there are these backup files being sent.
Well, that's because, I can tell you what it is, because we assume some kind of homogeneity. That each consumer buys a bundle of these things. So in some sense, our consumers are similar.
Mm-hmm.
I mean,
there's no externality.
There is no weird people who have these big files.
But even if it's the same person different times, one day they're backing up, next day they're trying to make that critical phone call, and now they can't prioritize the phone call.
That's fair. I can tell you that we worked on this problem for over 2 years. This was the only general functional form we could solve. No, I'm not saying that what you're saying is not right. I'm just saying that if we start going that way, you will have kind of special cases, and we'll never be able to solve a general problem. And that's a strange difficulty of network neutrality, because the internet is transporting so many things, and there's so many different types of people and so on. So we assume a certain degree of homogeneity. Okay, so let me say one the question, and then I will open to the public for the question. Is it possible to divide the bandwidth in classes to increase throughput and therefore increase welfare? And the answer is that it depends on a very esoteric feature of the demand function, which is the variation of the elasticity of content with respect to delay. So when you can create something in there, which is the elasticity of content with respect to delay, and if it's invariant, if it doesn't change as you go from type of content to type of content, then network neutrality is optimal. So I won't show you the equations. I'll make this available to everybody so you can see the equations. It's not really a hard problem. Once we got it that way, it's not hard. Maybe the most important thing is that we managed to get to this, so that total surplus is proportional to throughput. And once you have that, then the rest of it is kind of a relatively easy optimization problem, and that's what we did. Let me go to conclusions, and okay, so I won't show the equations. Oh, the investment. Yeah, I talked about investment. Okay, so in my opinion, network neutrality is a crucial issue of internet policy, innovation, and growth. Traditional network neutrality environment produced a lot of innovation and growth, and we enjoy right now. We show that network neutrality can be optimal for many utility functions, even with congestion, because we assume congestion from the beginning. Welfare in our setup, we think we have a pretty general utility function, and in our setup, welfare the total amount of content. And even in the presence of congestion, network neutrality maximizes welfare if the elasticity of demand with respect to transmission time is invariant with respect to content time. It doesn't much with content time. If the elasticity does vary, then we can characterize what you should prioritize, what you should not prioritize. So, and one of the weird results here is that sometimes you should prioritize the thing people don't want to be prioritized, and that's because the want not want is a partial derivative, while we are dealing with elasticities, and the difference between partial derivatives and elasticities allow you to have this kind of perverse results. Violating net neutrality can increase or decrease infrastructure investment. And do I have more conclusions? Sorry. Okay, this was trying to promote our next paper. So one response to the position of net neutrality is for the ISP to impose data caps to make money from net users. So we know that Ben and I wrote the paper on data caps. So essentially, we have a new theory on data caps. Essentially, we're saying that data caps make upstream goods closer substitutes, decrease their prices, give more surplus to consumers. Then the ISP can absorb their surplus by changing prices, by increasing prices. Anyway, forget about this. It's about another paper. So just thank you very much, and I'll hear your questions.
Thank you very much. I think that's the question. Are any?
Yes.
So one argument that you see here for net neutrality, maybe to talk about net neutrality and inequality more generally, is getting rid of net neutrality might allow ISPs to offer kind of like a really kind of low quality basic internet that had maybe, you know, Wikipedia and job hunting, and maybe even would have extra advertisements.
I think India has one that has only Facebook.
Yeah.
No, Facebook's offering one in India.
Facebook.org. You know, they have that.
So what do you think of that argument that ending net neutrality could increase internet access for very kind of low surplus people? Yeah.
Well, I would say that I would say that it really depends where we are on the internet growth, and if we're talking about a wealthy country or a very poor country. So I can imagine that in a very poor country that we have no internet, maybe Facebook.org has something to be said for it, at least in the beginning or for 5 years or something like that. But so there are countries in Africa that have adopted that, and that may make sense for them. But once you get to more developed countries, I don't think that's a good idea.
Thanks. Okay, really quick question.
So in your work, you're looking at welfare and career optionality, and career optionality doesn't care about the distribution. I'm wondering if you examine the idea of transfers between these parties at all.
No, we do actually care. I mean, allow transfers because we look at. We don't do Pareto optimality. We do total surplus. Total surplus is dollars of consumers, dollars of producers, ISPs, and dollars of edge guys. So taking $1 away from a consumer and giving it to the ISP doesn't allow this total, doesn't increase or decrease the total surplus, makes it remain the same. So we allow transfers. We do. Yeah.